Hello everyone. Now the next lesson, properties of limits. This one we used to learn in the I think first first period, right? When we talk about definition of limit, the informal one, the informal definition of limit, and they give you briefly about the properties of limit. Okay. Now today we're gonna do a little bit more and give you some more example how to write or when we can use the properties of limits. Okay, the first one, formula limit of constant. Say if d is a constant, then limit d when x upward to c equal to d. Okay, so this I will give you maybe some example later. Just say that this, for example, if we have limit, for example, limit 6, okay, when x approaches to 3, so this one gonna equal to 6 like this. Okay, and at the same time limit of the identity functions for every real number c, limit x when x approach to c equal to c. All these two definition we can see the next page for the example. Okay, so you will understand more than this one. Okay, now we go to the next one. See this one, everyone remember I gave you on the first period talk about the definition of limit. Okay, see this property of limit. Everyone still remember, right? We have 5 kinds. Actually, it's the operation of the mathematics. Like that one say is talk about the plus, minus, time, divide, and anything in terms of third form. Can be square root, cube root, fourth root, fifth root. Okay, so I may not repeat this again. We just go to the example right away. Okay, everyone still remember how to write, correct? For example, okay, now this one, you can write it down. Limit f plus g of x when x equal to c. You can rewrite down in this pattern, right? So this patterns, you can say, you can rewrite down another form is what? Just expand it, f of x plus limit g of x. Don't forget this one, you must write every time, okay? This one, x approaches c, and this one also, x close to c. Okay, you can write this way, it's minus a similar idea. Okay, so now we just see example right away from here, lower here. This one, if x of x may be a like that. Can you see example 1 here? If f of x equal to x squared minus 2x plus 3, then find limit f of x when x approach or x close to 4. Okay, or negative 4, very small here, negative 4 equal to limit x squared plus 2x plus 3 when x approach or x close to negative 4. Say x near negative 4. Okay, so in this case, you see this is a polynomial function. Okay, polynomial function. Actually, if you want to find limit of this one, it's very easy because it's already simple term. Okay, then you just replace x, right? Replace x equal to negative 4 in the function right away. But if this one, just say, do this one. I rely here. Maybe I can explain on the top here, like bigger, right? If the question f of x equal to x squared minus 2x plus 3, then they want us to find Find the limit f of x when x equal to or x close to -4. Equal to limit x squared minus 2x plus 3 when x approaches -4. Okay, so in this case, if the question did not request you, because it's a polynomial function, if the question did not request you to show the work, actually, for example, like a multiple choice, and this one can be like in SAT, it's really easy. You just replace x, right? Like this one, you just replace x in here. X equal to -4. And then you simplify. That's the answer right away. You can replace in here. But if question asks you to show the work, okay, show the work, then in this case, you have to use the property of limit to write down. So in this case, they do have minus and plus sign. So you use the property of number 1 and number 2 here. Okay. So in this one, how you write down, if show the work, okay. So then gonna be what? Write down, you can expand it, this one become x squared, x approaches -4 minus limit to x approaches -4 plus limit 3 x approaches -4. Okay, so when x limit or lim x squared means limits x time limit x, okay, and then x approaches -4, and then this one you can take 2 out, similar writing like in the sequence series, okay, so become 2 limit x when x approach -4 approach, and then this one plus limit 3 when x close to -4. So then you just, after this, you just replace x, right? Substitute x with a -4. So become -4. And this one is a -4. Don't forget when you replace the value of x, right? Equal to -4 here. The limit word here, no more writing here, okay? So then minus 2 times -4 plus 3. Now, this the one from the definition. See this? Okay, same as this x where or from the period one, the first page when they talk about the constant, right? If the, can they go back there? Let's see. Let's see. The first one here. This here. This one. Okay, this example. So if limit of the constant, this one I gave here. Okay, they're equal to d. Everyone still remember that one? Okay. Maybe I erase this one. No. See this one, okay? This is one. Okay, this definition or this formula here is this one. So that means limit of the constant be equal to constant. If limit 3 equal to 3 here. If limit 4 equal to 4, limit whatever, okay, d equal to d. Okay, now we come back to our example. Go back to here. Okay, so now this one gonna be then you just simplify this one, that becomes 16 and plus 8 and then plus 2. So equal to 20, 18, 16, 27, right? Okay. Okay, that's the one if you like that. But again, it show the works. Once you understand the meanings, you can skip some step here. Like from this step, like this step, right? From this step, you may not need to write. Okay, this one. So you just simplify on this one, this one. So from this one, you can simplify in, write it down, right? Become -4 like this, right away. Instead, you're gonna write that step. So become 2 times -4 and plus 3. Okay. So you can skip this step. It's okay. Okay, once you understand the meaning and the idea how to write down. But again, if question request show the word, you should write this one at least. Okay, I mean this one. Okay, but in multiple choice, you just replace x right away. X in the here or from here, right? Replace x equal to -4 right away to this function, and then you get the answer. You get the same answer. Okay, then don't forget the pattern of a polynomial, because already same pattern, you don't need to simplify. But if you're gonna use table, you still can use. You're gonna get the same answer. But why have to use table? Because table is then a kind of tedious one now, right? It take too much time. And if the exam they don't allow you use calculator, then the table is kind of tedious and slow, right? But again, that's why. But you need to know first, and then you can go this step, and that's when you can omit of the you can skip, may not need to write down. Okay, so now go next. This is the example when it's a polynomial. Now we go to the next example. If the function is a rational function, how to do? Okay, it's a rational function. So I may erase some here, right? This one. Okay, now you can see this one, rational functions, limit of rational function. See the example. Okay. If f of x equal to x cubed minus 3x squared plus 10 over x squared minus 6x plus 1, find the limit f of x when x approaches 2. Okay, so in this is a rational, right? So our step 3 step, remember, you replace x right away, the first step, x in the functions. It couldn't find it. It come out with the become 0 over 0. Remember the one, infinity over infinity, or undefined. Some case undefined sometimes can be the answer, but especially these two things, 0 over 0, infinity over infinity, then we have to go the next step. Because it's undecided, they may have answer have value of y. So then if couldn't do it, go third step is use table. Table is the last choice. You're gonna select or pick to do the calculation. So in this case, see, we do the first one, right? Maybe I write down here, say question example here. Say if f of x equal to this a function x cubed minus 3x squared plus 10 plus 10 and then divided by x squared minus 6x plus 1. Okay, and then question 1 us to find limit of this function. This one to 5, okay, 1 to 5. When x approaches what 2, so the 1 to 5 this one. Okay, so in this case, this is a rational function, correct? So the first step, how you replace, correct? Replace if say if f of x here if x equal to 2, right? You can take limit maybe like this way better. By replace x. Or can take this way, it's okay. So become 2 like this. And this one become 2 cubed minus 3 times 2 power 2 plus 10 over make straight line look nicer. So become 2 power 2 minus 6 times 2, 6 times 2, and then plus 1. Then you simplify what we have, 8 minus 12 plus 10, right? And over 2, 4 minus 12 plus 1. So what we have, 18 become this one 6 over 5, gonna be what, negative 7, right? Come out negative 7. So we have 6 over 7. You see this case, this function when you replace direct x equal to s, this one, replace x equal to 2 in the function right away. Then you come out, this one is not in this condition, correct? So then this is a limit answer. Okay, but this way, if you repeat this way is when multiple choice, they don't need you to show the work. Then you just heard because the timing, right? So you just do and replace in this way. But if show the work again, you if you like this one, if maybe this question is a 4 points, I may give you 2.5. So in this case, you have to show the work. But before you're gonna do the show the work, you can go to the second step, simplify, right? Simplify next step, because again this one can work already. So the second step, simplify, you don't need it because we can get answer. But even though you're gonna do simplify right away, this one you cannot simplify because this is a lowest term already for the numerator here. Cannot factor, cannot do anything. And also this one also couldn't do any factor or simplify. So simplify doesn't work for this case. Then otherwise you have to go third step, use table. Again, table is the last choice. We gonna think this one, that's gonna be the last choice. Okay. So now after this only doesn't need show the work, you get the answer. But how to show the work? Then use property of limit by using the quotient pattern. Okay, how to do it? How to show the work? Okay, now write the property of limit. So from the question here, you just take limit both sides. Okay, take limit both sides from the example that give to question give to you here. Take limit both sides. Limits. Oh. Limit of f of x when x approaches to 2. Okay, and then this right hand side limit x cubed minus 3x squared plus 10 over, you can write this one right away, okay, or then this one, limit of x squared minus 6x plus 1. Oh, sorry, this one must have line limit also, don't forget. Must lie and the bottom and the lower here, x approach. Maybe I erase it. Okay, this one must like have to, 2, and then divide it. This one should equal sign here. Plus 1 when x approaches to 2. Okay, so actually this one, another word before this one, you can write it down like this one, right? From this one, right? Before this line, you can write it down. Limit like this. Take limit both sides. X approach to 2 here, and x cubed minus 3x plus 10 over x squared minus 6x plus 1. You can write this one also. Actually, the step, have to write this one first, and then just come to this step. Okay, but because sometimes if you know this one, you may not need to write, you just write this way. Can be either way, okay? But then actually this one first, and then this is the next step. This one next step. Then after this you can write like this one, similar idea. Okay, you can write this one. Or but if you know this step, this two line, this two step, you can omit it also. Once you write this one, okay, you can replace x equal to 2 right away. Replace x here. Okay, so become replace 2 power 3 minus 2 power 2 plus 10 over 2 power 2 minus 6 times 2 plus 1. You can write this one right away, and then you simplify, they will get the same answer, which is equal to, it should be equal to this one, right? You can try, same. So it's going to be negative 6 over 7. Okay, so if like the way of the lighting for the by using the property of limit, it depends. When you have this one line is enough, or if you want to light more, I mean actually they should have these two steps, right? You expand this one first, you expand it, and then when you expand it, then just replace x equal to 2. Okay, either way, okay, but at least you must use the property limit, show the concept, because it's a rational, so you have to use a rational pattern to how to say, identify first before you get to replace the number to get the answer, final answer. Okay, so that is a rational function. Okay, this is a way when you're going to use property limits, when you're going to use. And it's necessary also, you need to write down. If the question request again, request you show the work. Okay, now we go next example. 1, 2, 3, 4 should be this one. Now I'm gonna delete, should be okay, right? So I leave it this one. I delete this one. Now see this, the bottom here. Now see the example 3. Okay, example 3. So you see, if f of x equal to x squared minus 2x minus 3 over x minus 3, find the limit f of x when x approaches 3. You see, this example is similar to the homework I let you do exercise 14.1 question 1 and explain in the Zoom also. Okay, very similar. Those first step, do the same way again. First step, this one, right? If I line this way, okay. The first step is what? You replace x, right? X equal to 3 in here. If you replace this one, f x equal to 3. So you're gonna have what? 3 power 2 minus 2 times 3. And then minus 3 over 3 minus 3. So you see this one come out, become the bottom becomes 0, so undivided, right? And the top, this one is a 9 minus 6 minus 3, so becomes 0 again. So they come back to this condition again. Okay, so the first step couldn't do it. Now second step, what the second step gonna do? Simplify, right? Simplify, then this one you can see can simplify, all right? Simplify, you can see you can write this one first. You can write down f of x here equal to x squared minus 2x minus 3 divided by x minus 3. So from the question, this is a function equal, right? Then you, from this one, you can simplify, correct? You can factor on the top, gonna be. Now, I should separate this one down, right? So you won't be confused. Okay. So now this one you can factor it, right? Gonna be x 3 1. So this one negative, and this one should be plus, right? Okay. So 3 2 negative 2 negative 3, yes. And then the bottom is what? X minus 3. Okay, then you see this one can cancel, right? This one can cancel it. This one similar like previous example also, you remember from last lessons. So this one you left x plus 1. And you remember actually this one become like another, we can name it to be like a function g of x. That's will related about the next lesson you're gonna learn about the removable discontinuity. Okay, but right now we live in this way first. Okay, remember? So equal to this one. After this, now once you simplify, then you take limit, both sides. Okay, that's a way you have to write down. Make sure this, I really care about how to write down. The idea of writing for the limit of functions. So you write down, you take limit both sides, right? Limit f of x when x approaches to 2, right? To 3, sorry. And then equal to take limit this one. So limit x plus 1 when x approaches to 3. Okay. Once you take limit both sides, then because question 1 you find limit of this one, which is mean this one, correct? Now, after because you simplify like this, then you can replace x with a 3 right away. So from this one, you replace 3 right away, become, or you can write down here. Save the space. So become 3 plus 1. That's equal to 4. Don't forget, once you replace x, the limit word, this set, the limit and the pattern is gone. You don't need to write down. Once you replace x, the limit doesn't need to write it down anymore. You have to get the number right away. So this question, the limit of this function for this question is equal to 4. Okay, is equal to 4. And then I think we have one more. Anyone understand? Sorry. Okay, so the rational function in this pattern, the one we can simplify, gonna have more action, have more meaning later on. Okay, but at least you see this one first. Okay, so and then we're gonna learn how to plot graph. This one, like last year you learned how to plot. Like this one, remember, if we plot graph, this one, which we have to see find what asymptote, right? Horizontal asymptote, vertical asymptote, right? And then find the x-intercept, y-intercept, something like that. So in this question, you remember what the vertical asymptote? Everyone can answer vertical asymptote? 3, right? If you plot graph somehow like this, correct? 3 here gonna be vertical asymptote, should be straight line, okay? Like this one. We're gonna plot graph this one later, okay, in detail. Okay, so because this one, right, x shouldn't be 3 if 3 become asymptote line or the open dot, remember from the first example. So this one gonna be 3 here, and then asymptote, vertical asymptote. Horizontal asymptote we have or not? Doesn't have either because the degree is higher than the bottom. So then after this, you just plot, right? The graph can be either this side or this and this side. Then you find x-intercept, y-intercept, that's all. X-intercept, y becomes 0 and replace y-intercept, x becomes 0, right? X becomes 0 in this case gonna be what? 3 gonna be 1. So y-intercept gonna be here something and you plot graph. Okay, but I omit the plot graph, right? This question first because we the time almost finished. Okay, so we go next one first. This is remind last year you learned how to plot graph. Everyone still recall? Everyone remember, right? Okay, now we go. I think I have one more example. Let's go. The last one. Okay, I have to delete it. Erase it somewhere here. Okay. Now I think I need more space, so I erase all on the right hand side. Okay. Maybe erase all. Yes. Leave it that way. Okay. Now see the example number. Example 4. Example 4. Maybe I use this color. Example 4 here. Limit of different quotient. Actually, this one, we come back to this one. What you still remember this pattern? This is a different quotient of a function is given by this. Actually, this one is what? It's the slope of tangent line. Actually, this one is the slope of tangent line. Okay, it's a slope of tangent line. So then we see example here. Okay, these are similar, right? Then say question give you f of x equal to x squared, find the limit of f 5 plus 5 minus f of 5 over h when h approaches 0. Okay, So how to do? I lie down here, like bigger, right? Because the bottom too small. If f of x equal to x squared, then they want us to find limit of 5 plus h minus f of 5 divided by h when h approaches 0. Okay, so I erase all I think. Now, how to do? You see, this one is kind of part of, it's a concept of composite function. Everyone remember that one, composite function. So this one, the whole thing here is a f of x, correct? So we rewrite it down, rewrite it become, we can simplify it first before we find out the limit of that one. Okay, so we simplify it. Become f of 5 plus h minus f of 5 divided by h equal to, you see this one, because f of x equal to x squared here, right? So you just compose this one inside. Okay, gonna be, this one gonna be 5 plus h squared minus, and this one f of 5, right? So 5 compose that, become 5 power 2 over h. Okay, that's a way. Then after this, you expand it, right? Expand it. So become 5, 5, 25 plus 2, 5, 10h and plus x squared power 2 minus 25 over h. Now we simplify 25, negative 25, cut. So we left 10h plus h squared over h. Now this one, you can take the common factor h, right? So become 10 plus h over h. And then this one cancel. So this one we left 10 plus h. Okay. So then after this, in general, we try to it can simplify. You simplify, take the function, take the function out like this, and simplify first until to lower term. After that, you take a limit for both sides. From this left hand side, this one, right? From this one, from the left hand side, if you rewrite just like this one, right? Become f5 plus h minus f of 5 over h equal to this one, correct? This one actually you should lie down like this. Then you take limit both sides. Then you limit, sorry, take limit, limit of f5. So we take limit for both sides, limit of f of x, maybe. Take limit f of 5 plus h minus f5 when x approaches h plus, no, sorry, should be, then now h not x, h approaches 0, and this one over 5. Okay, so then this one gonna be, and this side you can take limit of 10 plus h. when h approaches 0. Okay. Okay. After this one, this one question. This one should have F on the font. Sorry. I want to use this one should have here, right? I use the same color. Should have F on the font. And this one already have F. Okay. Now come back. Right. Then you take limit both sides. After that, you can replace H equal to 0 in here. Okay. So become 10 plus 0, then equal to 10. So then from the equation, limit f of 5 plus h minus 5, f of 5 here over h equal to 10. So the answer equal to 10. And you can say this is actually the slope value of tangent line equal to 10. Okay. So I think that's all for today. And then you can start to practice for exercise 14.2 for the how to use the property of limits. Okay, I will post in the GC and then you take a look what question you have to do. Okay. Okay, I think that's all for today. Okay. Bye bye.